Good morning, teacher! Good morning, classmates! Today, I will discuss Lesson 8, Finding the Prime Factorization of Whole Numbers. First, the objectives of this lesson. At the end of the lesson, the pupils were able to: Number 1, use divisibility rules to find factors of a whole number. Number 2, use factor 3 to determine as the prime factors of a whole number. Number 3, use continuous division to determine the prime factors of a whole number. And number 4, write a whole number as a product of its prime factors. Okay, let's start! First, what is prime factorization? Prime factorization is a way or process of finding the prime factor of a number. Prime factorization is similar to factoring a number, but it considers only prime number as its factors. Now, do you still remember what are prime numbers? Prime numbers are the numbers that have only two factors, 1 and the number itself. For example, 2, 3, 5, 7, 11, 13, 17, 19, and so on are prime numbers. There are various methods for the prime factorization of a whole number. The common methods are factor 3 and continuous division method. Factor 3 is a way of expressing factor of a number, specifically the prime factorization of a number. In factor 3 method, the factors of a number are found and then those numbers are further factorized until we reach the prime numbers. Now, how to use the factor 3? In order to use the factor 3, let's follow these steps. Now, let's find the prime factors of number 72 using the factor 3 method. Step 1. Let's write down the number 72 at the top of the factor 3 and draw two branches below. Step 2. Think of two easy prime factors of 72 with the aid of divisibility rules. And 72 is divisible by 8. Therefore, 8 times 9 is 72. So let's write the pair of factors 8 times 9 as the branches of the tree. Next, continue the procedure until each branch ends with a prime number. Factors of 8 are 4 and 2. Factors of 9 are 3 and 3. And 4 is still a composite number. Remember, if the numbers were not primes, then we should continue to split them into factors until there was a prime number at the end of each branch. So, factors of 4 are 2 and 2. We highlighted the numbers 2 and 3 as they are prime numbers, so the branches will stop here. And last step, write the solution. Select each prime number and express them as a product. Therefore, the prime factorization of 72, 2 times 2 times 2 times 3 times 3. Okay, classmate, do you understand? Okay, very good.
Now, let us try bigger numbers. Let's find the prime factors of 120. Again, in step 1, we write 120 at the top of the tree with two branches below. Next, write down the pair of factors as the branches of the tree. The number 120 has many factor pairs. But with the help of the divisibility rule for number 12, it is easy to choose 12 and 10. So we have 12 times 10. Step 3. Continue until each branch ends in a prime number. Both number 12 and 10 are not prime numbers. So two branches are extended from each number and filled with their factors. Factor of 12, 4, and 3. Factor of 10, 2, and 5. Here we have highlighted the numbers 3, 5, and 2 as they are prime numbers. So the branches will stop here. However, 4 is not a prime number. So we need to continue the branches for this number only. Factors of 4, 2, and 2. Now, we have each branch end in a prime number. And so, this factor tree is now complete. Last step, write the solution, select each prime number, and express them as a product. So the prime factors of 120 are 2 times 2 times 2 times 3 times 5.
Next, prime factorization using division method. Here are the steps in division method. Now, let us do the prime factorization of 72 again using the division method. The first step is to divide the number 72 with the smallest prime number. So, since 72 is even number, it is divisible by 2 based in our divisibility rules. So let us divide 72 by the smallest prime number 2. 72 divided by 2 equals 36. Divide 36 again by 2. 36 divided by 2 equals 18. Divide 18 again by number 2. Remember the first and second step? Divide the number by the smallest prime number that will divide the number exactly. So again, 18 divided by 2 equals 9. Now, if we divide 9 by 2, the answer is 4.5. We get a fractional number, and the factor cannot be a fraction or a decimal number. So, proceed with the next prime number, number 3. That is 9 divided by 3 equals 3. Then next, 3 divided by 3 equals 1. We can't proceed further as we have obtained 1 as our quotient. And last, multiply all the prime factors. Therefore, the prime factors of 72 are written as 72 equals 2 times 2 times 2 times 3 times 3.
Divided by 2 equals 60. Then, divide 60 by 2 again because 60 is an even number. It is divisible by 2. 60 divided by 2 equals 30. Same procedure. Let us divide 30 again by 2 since 30 is also an even number. 3 divided by 2 equals 15. Then, divide 15 by 3. We will use the prime number 3 because 15 is divisible by 3. So 15 divided by 3 equals 5. And last, 5 divided by 5 equals 1. Again, we obtain 1 as our quotient, so we cannot proceed further. And last, multiply all the prime factors. Therefore, the prime factorization of 120 are 2 times 2 times 2 times 3 times 5. Okay? You understand our lesson? Okay, very good.
And remember, prime factorization is the process of finding prime numbers as a factors in multiplication. Use divisibility rules in determining the possible factors of a number. To find the prime factorization of a number, use the factor tree or the division method. And that is the end of our discussion. I hope you learned a lot from our lesson. Thank you! Goodbye, teacher! Goodbye, classmates!